Hi everyone. In this video, we will see the operation of single phase to single phase step-down cycloconverter, a shunt-adapter transformer configuration with the R load. It is a specific type of power electronic converter used to change the frequency of AC power. So the cycloconverters directly converts AC from one frequency to another frequency without any need of DC link. So this is a circuit for shunt-adapter transformer configuration with the R load. If you look at the circuit, it has four thyristors. Thyristors are grouped as positive group thyristor P1, P2, and negative group thyristors are N1 and N2. So during first positive off cycle from 0 to pi, when the point B is made positive with respect to C. Now if you look at the circuit, the SCR P1 is being in the conduction mode when it is given a gate signal. So the current flow through the positive point P, B, then SCR P1 and load, then it comes to the negative point O. So the current flow in this particular direction. In the negative off cycle from pi to 2 pi, when the point C is positive and B is negative. Now the SCR P1 is automatically turned off by a line commutation. So if you see SCR P2, the P2 is triggered simultaneously whenever you give a gate pulse. So if you look at the path for the current flow direction will be from positive point C, then the P2 SCR, negative point through load, it goes to the negative point O. The current flow direction is like this. So the direction of flow of current through load remains the same as in the positive off cycle. In next moment, again point B is made positive with respect to C. So C become negative now, and if you see the SCR, the P2 is automatically line commutated so that the SCR P2 is completely off and making the SCR P1 gated. So P1 is starts conducting again. So the current path again becomes in the previous case when the SCR P1 was conducting. So it is observed that the direction of flow of current through the load remains same in all the three off cycles. Look at the waveform here. The current flow is same for first three cycles. So I will indicate here. So we'll have first three cycles, the current flow direction is same. In other words, the three positive off cycles are being obtained across the load to produce a one combined positive off cycle as the output. Similarly, in the next off cycle from 3 pi to 4 pi, when the point C is again positive with respect to B. Now the SCR P1 is automatically switched off. Now instead of SCR P2, the SCR N1 will start conducting as soon as if we give a gate signal. Now instead of SCR P2, the SCR N1 is followed by us and it is gated. So if you look at the path for current flow will be from point C, load, then SCR N1 to the negative point B. So the direction of flow of current through the load is getting reversed. In the next positive off cycle from 4 pi to 5 pi, then the point B is positive with respect to C. So SCR N1 is automatically turned off and SCR N2 is in the conduction mode. So N2 starts conducting, and what happens is the path for the current flow becomes from positive point O, then load, then SCR N2 to the negative point C. The current flow direction is like this. So the direction of current flow through the load remains the same. For the next off cycle of AC input, when the point C is positive and B is negative, then the SCR N2 is automatically switched off and again it makes the N1 to conduct. So the current flow through the load again remains in the same direction. So we can produce one negative off cycle at the output by combining three negative off cycle offs of the input. We clearly observe this waveform. Three positive off cycles are the output by the SCR P1 and P2, and three negative off cycles of the input AC are combined to produce one negative off cycle at the output of SCR N1 and N2. So it clearly indicates that the input frequency 50 Hz whatever we are supplying here is reduced to 1/3 at the output across the load. If you see the advantage, it is used for direct AC to AC conversion. The cycloconverter circuit does not need any DC link, so we can directly convert AC power without any having any DC stage or DC link. So this of course increase the efficiency and reduce the component count. And also we can use cycloconverter to provide a variable frequency output, which is useful for various applications like a motor drive, where we want to have a precise speed control is required. So it is used in many applications, controlling the speed of a large type of AC motors in rolling mills, cement mills, and mine host, and also used in power system to interface the different power grids operating at different frequencies. Thank you.